This paper was presented at the JCT Traffic Signals Symposium 2023 in Nottingham, thanks to the support of AGD Systems, INRIX, Message Maker Displays, PTV Group, Simplify Systems, Smart Micro UK and TRL Software.
Hey, good afternoon everybody. Going back many years, I used to be kind of plugged into the UK traffic control, traffic management kind of area. Did a lot of work with my colleague there, Tony Sharp. We did a lot of work on motorcycling engineering guidelines, which I think won the Prince Michael Award, and then we did a lot of stuff on motorcycles and bus lanes. Topaz is one of the groups which I was sort of kind of instrumental in setting up. So there's a lot of work I did in the UK and puffing crossing, etc., etc. But since about 15 years ago, or over, just over, what I want to do is give a background onto what I'm doing now and the European policy framework, sort of kind of framework, cooperative intelligent transport systems, hybrid communication, and what are the current sort of deployment activities in the CITS kind of area, and service delivery steps towards creating the end-to-end ecosystem. So, I mean, why are we doing all this? I think we all know that we have issues with increased traffic congestion and the consequences of that on the environment, on health, etc., etc. It's costing billions of pounds. I mean, how do we deal with this issue? It's not sustainable. So, and if you look at the traffic growth over the next 15, 20 years, it's something which we obviously going to be faced with some major issues here. I think we're already seeing some global changes with all the flash floods and all that kind of stuff happening around the world. If in the audience, are anybody aware of the EU ITS directive? Can I have a show of hands who knows about the EU ITS directive and the delegated regulations? National access point? Okay, right. So the reason why I'm here today is basically, before we kicked ourselves out of Europe, we were heavily involved in developing the European policy framework around the deployment of ITS, as it were at the time, and what was needed then to kind of roll out the deployment of ITS in a more sort of controlled, harmonized way to ensure interoperability across borders in particular. So there was action plans, 24 action areas, what the Commission kind of drafted. From that, it resulted in the EU ITS directive, which then kind of captured 6 of those action areas and labeled them as priority action areas. And I'll come to those in a bit. So the whole idea was trying to coordinate in a sort of more harmonized way the rollout of ITS across Europe. So, and what that meant was the roles and responsibilities of the public and private sector, how do we kind of bring them and get them to talk to each other, cooperation, and also data standards, specifications, to ensure this kind of like interoperability across borders. I mean, we had UTMC, we talked about systems interoperability, many years ago. Here we're talking about data interoperability, and how we're going to deliver services in the future, in the vehicle itself, which in a much more consistent, harmonized way, okay? So interoperability is the most important bit here. So as I just mentioned, the whole idea was to try and get public-private bodies, entities to talk to each other, because there's a lot of information which for example, the OEMs and third-party service providers, public sector, we have a lot of data, but it's putting some sense to the data. What do we do with that data? We can't just easily share that data. For future services, we need to be able to put some kind of structure, some sort of format on the data so that it's usable, use and reuse of that data. And obviously, there's licensing issues around, whether privacy, for example. So the 6 priority action areas were, first one was mobile traveler information. The second priority action area was real-time traffic and travel information. That's an interesting one. Just hold on to that thought for a minute. The third one was road safety-related applications. E-call, I think we're all familiar. That was priority action area E. And then there was a 5th one, which was looking at safe and secure freight and truck parking. That's where the motorways are associated service stations. This one in particular, the road safety one, is quite important one, because here there's an obligation on all of us to ensure that the roads are safe and fit for the purpose. And that not just the public authorities, as the private sector as well, okay? So because, as I said, they hold a lot of valuable information. So some of the examples given in there, the use cases were temporary slippery roads, and also any obstacles which may be ahead, unprotected accident areas, short-term road works, reduced visibility, wrong-way driver, that kind of typical road safety-related use cases. So the whole idea was, how do we exchange it? We need some suitable platform to exchange data. So data can exist in many different formats, okay? I mean, we in the UK have a very devolved kind of setup. Road authorities have been given charge of how, and what they do with their data, mostly, right? So where some European countries, especially the Dutch, have a very good handle on this. They have created what's called the NDW. So they basically, the federal government is responsible for all of the data in the country, okay? That's it. The national roads and also the public roads. So the whole idea was DataX2 or any suitable machine-readable format. So we need to put some structure, some format to the data where we can easily exchange between different entities to try and create those services that I just talked about. Okay, I mean, we're familiar with how we deliver services now. I mean, we've been doing this for over 20 years, right? So VMSs, web services, TMC, RDS, TPAG, that kind of stuff which we're familiar with, and how we get the intelligence from the road sensors, CCTV cameras, crowdsourcing, and the delivery of information through different dissemination channels like VMSs, et cetera, et cetera. But I think we can do more than that, and that's what Europeans actually been focusing on now. So we've got the might of the Europe, the 27 member states, all working together, okay, to try and see how can we progress from what we're doing now, from ITS to beyond, okay? So this is where the C in front of the ITS comes in, cooperative ITS, right? So we have intelligence from sensors which are sparsely sited, populated. We have VMSs on the motorways, big gaps in between where there's no information to the driver, right? So the whole idea of this priority action B, real-time traffic and travel information, the whole idea is contextualized real-time traffic information to individual driver, so they know exactly what information is relevant to them, not geographically, it's like nationally, but to them, where they're traversing in that bit of the road network. That's the important bit, okay? So, and how do we kind of get to, so what the European Commission tried to do in 2019 was to introduce another delegated regulation, kind of an obligation on member states to say, this is how you shall do and produce, kind of create a platform for delivering CITS services. It got knocked on the head at the last stages of its going through the processes because of mention of certain technologies in there, and there was a lot of kind of uproar about mentioning a specific technology, which I think it should have been pretty much technology agnostic at the time, okay? Right, so when I talk about CITS, I mean cooperative, so we gather the intelligence from anything and everything which moves in our road network. So we're talking about vehicles themselves. Now, vehicles are rolling off the production line with communication, connected capabilities. The Volkswagen is one example. There's many others. And also, the other ways of doing this, obviously, is we're talking about vehicle-to-vehicle communication. We're talking about vehicle-to-infrastructure communication, infrastructure-to-backhaul communication. So we're talking about everything, talking to everything which moves in the road network. That's kind of the aim here, right? And the other important bit is, okay, we have the communication now, but we also need to have this digitized transport infrastructure. Now, that's quite a difficult ask here because that relies on having up-to-date maps which are very important. So obviously it depends on the level of definition of the maps, base layer, how many other layers you might have on top of that. So ultimately the whole idea is whatever we see out there, we really need to put that to have that digital footprint, okay? So now we know we have the location referencing from GPS coordinates, so we know exactly where everything is within that digitized kind of whole controlled environment. Right, so the other important bit is communication, connectivity. So we talk about hybrid communication. So there's two types of communication. One is long-range communication, the cellular kind of stuff which we're used to, 4G, and now 5G. And also, we're looking at short range. Now, just to give you one example, I traveled from London to Nottingham, I think about 30% of my journey, I had no connectivity, right? So we live in modern times, okay? So we cannot always rely on saying we're just going to have one type of technology which will give us 100% coverage, or not even 99 or 98, 97% coverage, right? So there may be gaps where we might need short-range communication, the 5G or G5 rather, the 5.9 gigahertz, okay? That's a dedicated bandwidth which has been reserved for ITS applications. So we're talking about when we broadcast information, we're broadcasting on both channels, the short range and the long range, so that communication is always there. Okay, so when we talk about, I mean, we're all familiar with the term digital twin, right? But I think it's a bit more than that. I mean, maps are as good as the information they suck up from wherever they get it from. And what we need is authoritative information, and that comes from the road authorities. Okay? Now, road authorities, my kind of intel tells me that in the UK alone, I mean, how many people in the audience are responsible for making traffic regulation orders? Anybody? Do we know what traffic regulation orders are? Of course we do. Anyhow, so because of this dispersed data environment, road authorities are responsible for making traffic regulation orders. The only obligation on road authorities is that they need to advertise in the paper, and that's about it. Okay? Nothing beyond that. So in other words, they can store that information as a PDF file, Word file, or some machine-readable format. Where they store it, how they store it, nobody has control over that. So how can we have maps? Earlier on, we talked about reliable information navigation systems. The navigation systems are only as reliable as the information, how update the maps are. So how do we get to that? So we need to have some kind of standard right in the front where road authorities are capturing the data. There is a European platform called TNITS, Transport Network Intelligent Transport Systems. So that has been created. There's a standard which has been created, which is in the Delegated Regulation RTTI, Road Traffic and Travel Real-Time Traffic and Travel Information, which puts an obligation on road authorities throughout the European member states. When they capture the data, it has to be either TNITS or DataX2 conformant. Okay, so it's an obligation, which we obviously don't kind of sign up to because our decision to come out of Europe. Anyhow, so that's the main aim, is to try and standardize. So this is my kind of interpretation of how this might happen. So Darren, my colleague, alluded to the TROD, which is the Traffic Regulation Order data repository which we're trying to create, the data model which we're trying to create here, which is the interface with the road authorities, okay? I mean, we may have third-party service providers putting some sense to working with the road authorities, putting some sense to the data. So in other words, the data is in suitable machine-readable format. And from that TROD model, we could have a number of publication data feeds. One could be for parking, one could be for maps, it could be for other applications. And there's also a role for the national access points to play in this, as well as managing the privacy, security, and also the quality aspects. There are three platforms. We did we set up a trial going back a few years, which was part of the Interco project, Interconnected Corridors. The Belgians, French, Netherlands, ourselves were the partners. So the whole idea was to try and create this corridor where we could actually demonstrate the capabilities of CITS. We used a number of use cases for that purpose. The existing format, the platform is C-Roads, comprising 20 member states. Just imagine 20 member states with all that resource and the power and the intelligence which are drafting the functional and technical standards and specifications, as well as the quality requirements, the security, and the privacy requirements. So there's a lot of work being done to try and move from ITS to CITS and deploy real-time traffic and travel information services to the end road user in vehicle. And CCOM is another platform. So these are some of the use cases which were used as part of the trial. And UK, we looked at the in-vehicle services, roadworks warning, Glosso. This was the corridor, so we started from London, the A102, which is the Blackwall Tunnel, through to, the idea was to create it to the Dover, and then also to Paris, Belgium, and the Netherlands. Okay, so I'm not going to go too much into this because I'm conscious of the time. So this was kind of the corridor which we did the set up the living lab. Okay. So as I said, the use cases we looked at was hybrid communication, long range and short range. So we used Glossa, we had ITS-G5, and for vehicle signage, hybrid separate cellular services, and roadworks warning, hybrid and separate cellular. So in other words, we're delivering these services concurrently using long range and short range, just to demonstrate the capabilities. Now, Europe has lots of borders. How do you communicate information from one country to another, especially when you're using roaming services where you haven't got the local breakout? So the whole concept basically relies on interchange nodes. So these are interchange nodes which are basically country A to country B. The whole idea is if a UK vehicle is now, let's say, moving around somewhere in France, then the service provider in the UK knows where the vehicle is, okay? So if we want to get local services, on long range, short range is okay because it's broadcasting, it's sending to everybody. Everybody is receiving the information. Doesn't matter where you're from, but it's the long range communication. So the vehicle traversing in another country has to go back to its service provider, and we talked about the latency issues, especially some of these time-sensitive use cases like Glossa, for example. Not the map information, it's more the spectrum information, which needs to be done in real time, okay? So this is kind of a typical kind of systems architecture where there are a number of key players, entities, public sector, private sector, OEMs, all have a key role to play in this, in data, suitable data formats, data quality, okay? Just an extract of number of use cases which are actually being deployed in Europe now. Okay, so we're looking at emergency vehicles approaching, hazardous location notification, wrong way driver. These are actual use cases being deployed in Europe now using CITS. So we are delivering the real-time traffic and travel information to the driver in the vehicle itself, not relying on roadside, signs. So it's a continuous bit of information. There's no gaps in the information. And I said it's contextualized because the whole system knows where you are within the network, because of your location referencing. And one of the most important use cases, I think, which will revolutionize the way we do traffic management in the future is PVD, probe vehicle data. I don't think we will need sensors any longer in the future. We may need them for certain applications, that's for pedestrians. Everything else which has been built, this connected capability will be basically giving a footprint of where it is, which direction it's going. And that information will be so useful in making some very, very important decisions in regards to how we manage our networks in the future, and enable us to deliver contextualized real-time travel information. Okay, so the future journeys, as I said, we talked about levels of automation. Level 0, 1, 2, 3, 4. I mean, like I say, we got lane keep, we got adaptive automatic cruise control. These are there now. Okay, but that also brings about issues of liability. Where do they lie? Do they lie with the vehicle sensors? Sensors are there. Sensors will work if the infrastructure is reading off, is of high quality, high standard. Okay? If the signs are facing the opposite direction, the sensor is not going to know what the speed sign is. And we also talked about ISA, intelligent speed adaptation, or advice rather. That needs information from the roadside using sensors. But if we have everything coded digitally, everything will be, and the maps are always up to date, okay? Then that information could be got very easily and from the maps themselves, right? And in terms of, as I talked about issues of liability, we talked about driving, self-driving, levels of automation. So there's a lot of work which the road authorities have to, they play a very important role in maintaining the road infrastructure. But it also brings about a lot of kind of asset management, a lot of pressure on road authorities, and say, there's costs involved, resource involved, okay? So the whole idea is to try, and I think that the key is to try and move towards this term called naked motorways, is one which you use with having no signs, no physical sort of infrastructure, to where I think it's going to be a gradual approach. I think in the next 5-10 10 years, we will see these connected services being delivered to drivers in the vehicle itself. Okay, I think ultimately it's all about, comfort, safety, reliable journey timing, and the journey experience in general. Okay, I think that's what we're all striving towards. Thank you very much.
Thank you, Suku. While we wait for people to put their hands up, I have a question. We have lots of local and combined authority representatives here today. We all know where we want to get to with CITS, but we have, in local authorities, lots of ageing infrastructure and budget constraints. So what would be your advice to the local authority and combined authorities of things they could do now, given those budget constraints, that move them in the right direction towards the connected future?
I think, like you say, it's not just budget constraints, it's resource availability as well. Now, understanding that, so, I mean, there are two ways of dealing with this. One is bits of legislation. We say, okay, we're going to come down hard and say, you shall do it. But then the board of authorities will say, yes, we will do it. It's the money, it's resource. The other softer approach is basically kind of giving them the tools to do the job. Okay, that could be through advice, guidance, okay, or providing some incentive somewhere, either to third parties or directly, to try and get to where they're kind of heading towards this goal. It's not going to happen overnight because, as I said, for a long time, we have no control over the data. Data is the key to all this, to delivering all the services.
Stuff. Thank you. There's obviously the manual for smart streets as well, which is DFT and TTF. So check that out if you want to. There's lots of advice there. Right, questions? We have a question up here, please.
Hi there, I'm Matthew from the Government of Jersey. I was wondering, with the use of the probe vehicle data you're talking about, so maybe not needing sensors, stationary sensors as much, if every car was to have one of these tomorrow, would the 4G network be able to cope with it, or is it something that 5G will have to do?
Well, that's a very good question, that. Yeah, I mean, it depends on the frequency you're transmitting the PVD, right? You could send 10 messages a second. You could send 1 message a second. So you could kind of tailor it depending on the situation and circumstance. For example, if there's an incident, you could send you could increase the frequency. But normally, it'll depend on how all is aggregated. You don't want the actual information, it's aggregated information, but you could do through some edge computing as well. Yeah? So that's the plan.
Thanks.
Anybody else like to ask a question? No, I think you're good. Thank you, Suki.